Okay, hello mathematicians. We're going to keep looking at the review packet. I'm going to go over the next 2 pages. So this is the packet that looks like this. And we're going to go over these pages, which actually are all, these are all one multi-step problem. So let's go ahead. We'll read the instructions. Part 3, open response. Show all of your work, drawings, tables, and or computations. Computations are calculations. It's the math work that we do in the space provided. If you do the work in your head, explain in writing how you did the work. Okay, number 6. Jody collected data for her winter science project. The table below shows the data for snowfall for 1 week. So here's the table, snowfall for 1 week. Day of the week, amount of snowfall in inches. So as a good mathematician, I'm picturing this in my head right now, like imagining this much snow. So it snowed every single day this week. That's interesting. Okay, so Monday, 3 5/8 inches. So just so you can see what that looks like. Let's take a look. Here's my kitchen. Hopefully we can get this to... Okay, so 3 5/8 inches would be like if the snow fell 3, not all the way up to the 4, but every 1/8 of an inch are these little marks. So 1/8, 2/8, 3/8, 4/8, that's a half, 5/8, 3 5/8 inches. So that much in a day, like you can see kind of that amount. All right, that would be a pretty good amount of snow. Okay, so that was Monday. Tuesday, 2 3/4. So that's coming from the table again. Tuesday is 2 3/4 of an inch. So that would be 2 1/4, 2/4, 3/4. Okay, Wednesday, 4 1/2, 4 1/2 inches. So that was a big day. That's a couple of inches of snow. Thursday, just 7/8 of an inch. So not all the way up to 1 whole inch, just a little bit. And last Friday, 1 3/4 inches. So that would be like, here's 1 inch, 1 1/2, 1 1/4, 1 1/2, 1 3/4. Okay, so all together, and the question is asking us, let's see if I can get us set up correctly here again. What was the total amount of snowfall in inches for the week? Okay. And then we, of course, need to show our work. Oops. Let's get us organized. Great. Okay. So, if we want to find the total all together, we're going to have to add. Before I add, I'm going to go ahead and do a couple of things. I'm going to start with making my solution sentence. The total snowfall was some number of inches. I got that right from the question. What was the total amount of snowfall? The total snowfall was this. Now I'm going to make my estimate. So 3 5/8 is close to 4. 2 3/4 is close to 3. 4 1/2, I'll round up to 5. 7/8, I'll round up to 1. 1 3/4, I'll round up to 2. So I can do this in my head. You could write this down on a separate piece of paper in a different spot if you needed to, but 4 plus 3 is 7. 7 plus 5 is 12. Plus 1 is 13. Plus 2 is 15. So my estimate is about 15 inches. So I know my answer should be somewhere close to there. I ended up rounding a lot of these numbers up, so I know it'll be a little less than 15 inches. If I'm far away from that, I know I've made a mistake. Now, let's make our equation. What do we actually need to do? We need to say 3 5/8 plus 2 3/4 plus 4 1/2 plus 7/8 plus 3/4 is equal to, let's say, t for total. Okay, Now I'm going to add all of these values for the week, these 5 values together. You could do this in a bunch of different ways. You could add each one at a time, kind of 3 and 5/8 plus 2 and 3/4. And then the total of that you could add to 4.5, and the total of that you could add to 7/8 and to 3/4. I'm going to choose to add my fractional values together first, and then add my whole values later. So I'm going to write that equation, or I'm going to do some of my work over here on this side. You might want to choose a different piece of paper, or hopefully you didn't all try to cram it into this space because there's not really enough space. So we have 5/8. That's coming from the 3 and 5/8, plus 3/4, coming from the 2 and 3/4, plus 1/2. That was from the 4.5, plus 7/8, and then plus the 3/4. Okay. In order to add fractions, I know that I need to have all of these be the same size pieces. So they all need to have a common denominator, the same number on the bottom. I know that 8 is the least common multiple of all of these. That means that 8 is a multiple of 8, of course. It's also a multiple of 4. It's also a multiple of 2. So that's going to be the best one for me to use. So I'm going to change these ones that aren't in 8ths. I'm going to change those into 8ths. So let's start with 3/4. I'll just do this over here. 3/4. I want it to be equal to something in 8ths. Some of you might know this in your head. That's great. So what I need to do is multiply 4 times 2 is 8. Whatever I do to the denominator, I need to make a version of 1. It needs to be same numerator and denominator. So that means 2 halves. So 3 times 2 is 6. So this 3/4 is going to turn into 6/8. This 3/4 is also going to turn into 6/8. So let me rewrite the whole equation. 5/8 plus 6/8 plus, this one I can do in my head. What's 1/2 if I wanted to write it in 8ths? That would be 4/8 plus 7/8 plus one more, 6/8. Same from the same as the other 3/4. Okay, so here's all my fractional parts. They all have a common denominator of 8ths, and now I can add them together. 5/8 plus 6/8 is 11/8, plus 4/8 is 15/8, plus 7 more 8ths is 22/8, plus 6 more 8ths is 28/8. Okay. You could write that down, or you could combine like the 6 and the 4 into a 10 first, or there's multiple different ways to add these, but at the end, you want to end up with 28/8. Because I'm going to be adding these to my whole numbers, it'll be easier for me to think of this as a mixed number instead of an improper fraction. So if I want to change this into a mixed number, I think how many groups of 8/8 can we get out of 28/8? So let's see, 8/8 is 1 whole, 16/8 is 2 wholes, 24/8 is 3 wholes. So 24/8 is 3 wholes plus 4 more 8ths. 24/8 is 3, 4/8 is a half, so that's 3 1/2. Okay, now I've added all of the fractional parts. I got 3 1/2 inches. And what I have left is to add these whole parts. I'm going to do that on the other side where I have a little bit more space. Okay, so we'll see that hopefully. Okay, so we have 3 plus, that's from this 3, plus 2, plus 4, plus this 3 1/2, which is all the fractional parts. Okay, 3 plus 2 is 5, plus 4 is 9, plus 3 is 12. So let's do it actually like as if we were going to do order of operations. 3 plus 2 is 5, 5 plus 4 is 9. Just for a little order of operations practice. 9 plus 3.5 is 12.5. So the total snowfall was 12.5 inches. Is it relatively close to 15? Yep. So I'll give myself a little smiley. That seems to make sense. Great. And that's done with that problem. Okay. The next problem says, what was the difference between the day that had the greatest snowfall and the day that had the least snowfall? Show all your work. Okay, so we're seeing some math words here. Greatest, least, difference. So when we see difference in math, that means we want an actual mathematical difference. So for example, what is the difference between my niece's age, which is 7, and your age, which is 11? And that would be 11. If I wanted to figure that out, I'd say 11 minus 7. The exact difference between your ages would be 11 minus 7, which is 4 years. So that's a 4-year difference, we could say. In this case, we're looking for the difference between the day that had the greatest snowfall and the day that had the least. So take a look at the list here, the table. Which day had the greatest snowfall? Hopefully you figured out that was Wednesday. And then which day had the least snowfall? Hopefully you noticed that was Thursday. So let's go through our word problem process again. First I'll write my solution sentence. The difference between the day with least snow and most snow was blank inches. Okay. So I know my answer will go into this box, and I can think to myself for a second, will this answer be more than 4.5, what I started with, or less? Well, it'll definitely be less, right? Because it couldn't be that we got more than 4.5 inches of snow. The difference couldn't be greater than what I actually have on my greatest day. So now my equation will look like 4.5 minus 7/8 is equal to, let's say, D. All right. Last but not least, let's make an estimate. 7/8 is very close to 1 whole. That's easy for me to work with, so I'll just do 4.5 minus 1 is 3.5. So my estimate should be somewhere around 3.5 inches. So I'm hoping that or my answer should be somewhere around 3.5 inches. There's lots of different ways to do this subtraction, and we're going to be talking about it next week, actually, in the new work. You might have used a couple of different strategies. You might have thought about subtracting 1 whole and then adding 1/8 back, because 1 whole is a little bit, you've subtracted a little bit too much. You might have turned 4.5 into a mixed number. That would be 9 halves. And then changing that into 8s and subtracting 7/8. I'm going to show it on a number line. If you didn't get this yet, don't worry, because we are going to be going over it next week. Okay, so here's where I started at 4.5 inches. And I want to be going back on my number line because I'm subtracting. I want to be going back 7/8. So to make this easier, instead of writing 4 and 1/2, I'll write 4 and 4/8. Because again, we know from up here that 1/8 or 1/2 is equivalent to 4/8. So 4 and 4/8, and I want to go back 7/8. So I'll make a jump back of 4/8 first. That gets me to 4 holes. Now how many eighths do I still have left to subtract? 3. I have to subtract 3/8 more. So we'll make another jump back of 3/8. And that gets me to 3 holes and 5/8. So that is my answer. The difference between those 2 days, or those 2 snowfall amounts, is 3 and 5/8. You also, this is a great problem for adding up. So if any of you thought to do adding up, that was really efficient. 3 and 5/8 is very close to 3 and a half. So my answer is close to my estimate. I feel great about that. I'll give myself a little smiley. And we can move on. Okay, last part. Here we go. So if you didn't do this one yet, pause it, stop, and then come back once you've given it a try. So our same Jody measured the length of an icicle at 2 different times during the day. The first time Jody measured the icicle, it was 9.5 inches long. The second time Jody measured the icicle, it had begun to melt, and it was 6 7/8 inches long. Okay, so we're imagining an icicle hanging down off of like the side of a building or something. It started off really pretty long. 9.5 inches is like almost a full foot. So if we're looking at our ruler, I'm not even gonna hold it up this time, but we have like 9.5 inches, that's long. And then when it started to melt, when she came back, it was only 6 7/8. So it was about that long. So I guess it's kind of the opposite, because if you imagine hanging it off of a building, it's like it was hanging down to 9.5, and then it started to melt and drip to 6 7/8. Okay. It asks us to write an equation that can be used to find D, the difference between the lengths of the icicle when she measured it the first time and when she measured it the second. So just like we were doing on the previous problem, we know that difference is one of the ways that we think about subtraction, trying to find the difference between 2 values. So that equation is a subtraction equation. So this part of the problem is really actually pretty simple. It's something that we've been practicing doing on all sorts of word problems. 9.5 minus 6 7/8 is equal to D. Done. Solve the equation to find D. How many inches shorter was the icicle the second time Jody measured it? So this time we have our equations already set up. I'll write my solution sentence. The icicle was some number of inches shorter. Again, right from the question, how many inches shorter was the icicle? The icicle was some number of inches shorter. And then let me make a quick estimate. So 9.5, I'll just keep as 9.5. And then if I round 6 7/8, 6 7/8 is very close to 7. It's almost 7 holes. So I'll just subtract 7 holes. And that would be 2.5. So that's my estimate. Oops, sorry, I made that messy. Okay, now let's try to find out what the actual answer is. This time I'm going to use an adding up strategy. So this is exactly the same thing that we do when we add up using whole numbers, but it's extra helpful for fractions, I think. So if I start at 6 7/8, and I want to know the difference, the distance between 6 7/8 and 9.5, all I need to do is find this amount, and I can add friendly numbers until I get there. So the first jump I'll make, what makes sense? What's a good friendly number next to 6? 6 7/8? 7 holes, right? So I just need to add 1/8. That gets me to 7. Then I need to add 2 holes. That gets me to 9 holes. And then all I have left to do is one more jump. How to get to 9, from 9 to 9.5? Add a half. So to find my total distance, my difference here, I need to add these 3 jumps that I made. So 1/8 plus 2 wholes plus 1/2 equals D. I need common denominators just like always. Luckily 1/2 is pretty easy. I can do this in my head. I need it to have the same denominator as the eighths, so I can do that actually mentally. 1/8 plus 2 wholes, those stay the same, plus 4/8. Now I add them all together. 2 plus 1/8 is 2 1/8, plus 4/8 is 2 5/8. Let's check, is 2 5/8 close to my estimate? Yeah, sure, super close. So that feels good. I'll put it in my answer. The icicle was 2 5/8 inches shorter. And if I even go further as to think about what it would look like if I really measured it, here's 9.5 again. And then I melt to 6 7/8. Yeah, that looks like about 2.5 inches. So that feels great. I'm gonna give myself a smiley. Give yourself a smiley too, even if you didn't get these correct, because you've done a lot of hard work. Post a comment to me and let me know how you did, and we'll be back next time with the next page of review.